All right, so 4.1, any problems with number 1? Indicate whether the direction of rotation is clockwise or counterclockwise.
No.
Positive is counterclockwise. Anything negative is clockwise, right? Okay, number 2, convert each degree measured to radians. Anybody have any trouble with number 2? When you convert to radians, you multiply by what? 180 over pi or pi over 180. Which one?
Depends on pi over 180.
Pi over 180 because you want degrees on top that you're given and degrees on the bottom to cancel out. So you do 30 times pi over 180 and you simplify, guys. Right? So for example, come on. Y X. Uh-oh, my computer is officially not happy. Hey, shh. Hey guys, I don't want you talking about anything else while we're doing this, okay? Just everybody just pay attention, please. It's gonna go quick. So if you're trying to convert 30 degrees to radians, you multiply by pi over 180. Don't get your calculator out and just give me a decimal. In radians, we don't want decimals, we want simplified fractions in terms of pi. So we get rid of the zeros, right? Divide by 10. And 3 over 18 is 1 over 6. So that's pi over 6 radians. So 30 degrees is pi over 6 radians. All right?
If it wasn't divisible, like if it wasn't perfectly divisible.
Well, this isn't
like
perfectly
2 over
divisible.
7 or
Which is,
something like
yeah,
that?
you have 2 over 7. Or yeah, something like that. Just divide it as much as possible. Because you can have like 113 pi over 119. Like that's an angle.
Yeah.
It's not one that we would use commonly, but that's you know, simplified, whatever. I think that's simplified. All right. So anything else from 2? No? Going through these pretty quick. 3. Convert each degree measure to radians. Express your answer as exact values and as approximate measures. So approximate measures is just decimal 2. So if you have 2 pi over 7, then it's just type that in your calculator and write a decimal. Okay, 4? Any problems with 4?
No.
Convert radians to degrees. So you multiply by 180 over pi. Cross out the pi's, cancel out the pi's. Okay, pies, hungry, make me hungry. And then simplify the fraction, or write as a decimal. It says exact values and approximate. Okay, 5 or 6? Any questions about 5 or 6? Okay, 6a. Sketch each angle in standard position. In which quadrant does each angle terminate? So these angles that do not have any symbols are in radians, right? So this looks like radians, 17 pi over 6, no problem. This looks like radians because it's got a pi. This looks like it's just a 1, but remember, we talked about 1 radian. So if we're to sketch these, let me just...
56.25 or something?
no, it'll be about 57. 57 points. 0.3, yeah, something like that. But, okay, this is very important, everybody. Watch closely, please. Watch closely. So, 1 radian. A couple ways you could think about this. In the lesson, we drew this exactly. We got pretty close to this one. But think about this. Again, this is pi radians, you know that, which is equal to 3.14. So if you divide this roughly into thirds, right? Roughly into thirds, there's going to be exactly thirds. Then you have 1 pi is right here. This is 1 radian. This is 3.14 radians right here. So this is 3, this is 2, this is 1. You see that? So 1 radian, there's your sketch. Which quadrant? 1. Now let's go to C, because it's these ones that are going to be the tricky ones, okay? So C, watching closely. Now this is 17. You can also rewrite this as 17 pi over 6's, right? 17 pi over 6's. That's going to be the easier way to do this, so watch carefully. So if you notice that pi over 6 is right about here, that's 30 degrees. I think we did that already just today. So 30 degrees. Now, a second pi over 6 is going to be what degrees? 60 degrees. 3 pi over 6 is going to be, and this leads well into our lesson today, guys, okay? So this is 1 pi over 6. This is 2 pi over 6. Or that reduces to pi over 3. This is 3 pi over 6, simplifying to pi over 2. So 17 of these, well, we go 1, 2, 3, 4, 5, 6. This is 6 pi over 6, which equals just pi. 7, 8, 9 pi over 6, which equals 3 pi over 2. 10, 11, 12 pi over 6, which equals 2 pi. 13, 14, 15, 16, and 17 pi over 6s. So we've gone all the way around once and then ended up right here. See that? It's not hard, but that's what we're going to focus on today in today's lesson, 4.2. So this is quadrant 2. Right? Now popping over the degrees, let's do 650. Okay, this is 360. What's 360 plus 90? That's going to be 450. What's plus another 90? 540. Plus another 90, 630. Okay, and then 20 more degrees, boom, right here is 650. So what quadrant is that? 4. Good, got it. Awesome. Okay, okay, 789. Anything about 789 you want me to touch on here?
No, not really. So wait, actually, yeah. So
Hold that thought. Last day, okay, we talked about this after the lesson last day. I did not get to this. It was in the notes, but I, for some reason, missed the sign. The general expression for coterminal, actually, let me just go back to the notes here. Give me a sec. I should have this somewhere. Yeah, right here. We didn't do this yesterday, so let's just talk about this real quick. The general form of coterminal angles. If you have any angle and you want to find out another angle that's coterminal, you just add or subtract multiples of 360. You can go around one more time exactly to get another coterminal angle, or you can go around the other way and get a coterminal angle.
Just add 360.
So the easy way to be add 360, you're good. If the angle is in radians and you're like, pi over 6, how do I do that? Add or subtract multiples of 2 pi. Now, it's written a little bit differently in different books that you see, but multiples of 2 pi can be n 2 pi, or it could be 2 pi n. You'll see this one more often. So multiples of 2 pi. So plus or minus 2 pi n. No talking, please, guys. Guys, hey.
So like 7, 8, you just add 360 to 72.
Yeah. So going back to this question, coterminal angles, easy way to do that. Easy way to do that would be just to add 360. Or add multiples of 360. Add 720. Or whatever. Or subtract 360. This one, add 2 pi. Okay? How do you add 2 pi to 3/4 pi? Okay? How do you do that? Again, we're trying to focus on keeping our fractions, right? So, that's right. So 3 pi, pencil's upside down. 3 pi over 4 plus 2 pi. Well, how do I write 2 pi as thank you. 8 pi over 4. Okay, don't fight, boys. I'll kick you out of the sandbox here. All right, what's 3 plus 8?
11.
11 pi over 4. Can you reduce that? No, done. That's another coterminal angle. We've just gone 2 pi around and boom, we've stopped on the same terminal arm. Got it? So this one, 72, 360 plus 72 is what? 432? That one works. And a negative 2 you can subtract as well. No big deal. Okay? 188 or whatever it is. 188, 288, 188, 288, 288. Okay, good. 9, no. Expression for the angle coterminal. 9. So 135 plus 360n. That's all you need to do. All the angles coterminal with this one, 135 plus, or you say, well, you could do plus or minus 360 degrees n, where n is any whole number. Or you could just do 135 plus 360n, where n is any integer. So that is positive or negative. I was asked about 14. Okay, 14 will take a little bit more time to work through, but let me just read it quick. Rotating water sprinkler makes 1 revolution every 15 seconds. The water reaches a distance of 5 meters from the sprinkler. So if the sprinkler is at 0, 0, 5 meters around, so the radius would be 5 meters. The time, 1 revolution, that's 2 pi radians per 15 seconds. So 2 pi over 15, okay, is how long it, 2 pi radians per 15 seconds. 2 pi divided by 15. What is the arc length of the sector watered area when the sprinkler rotates? 5 pi over 3. So you could sketch that out on the circle. Okay, it looks something like this. You know, sketch out a section. And then what's the formula? A equals theta r. So the arc length equals theta, this one, times the radius, 5. Easy. How could you find the area of the sector watered in part A? What's the area of a circle?
Pi r squared.
Pi r squared is the area of a circle. So whatever section of 2 pi that angle would be, that's the same section of pi r squared. So pi r squared is the area of the whole circle, and then times, 5 pi over 3 over 2 pi. That's the section of 2 pi that is. So you just get that section. Again, I'm not writing this down, just kind of walking you through it. You might have to just take a little look at this. I'm going to let you attack number 14 somewhere on your own. Okay? Okay, that's all the comment I'm going to make on the homework assignment. Please finish that if you haven't got that finished. I think I asked you to pick one between 14 and whatever, 21 or whatever. But I'd like to get on to 4.2 now. Okay, everybody good with that? All right, let's do 4.2. No, there's no handout notes package for this one, no.